Right, now let's have a look at ticker tape timers, right? Ticker tape timers are quite an important part of our study of mechanics, because this is kind of tying up the experiments and the Newton's laws of motion. They're putting them together. Okay, what is a ticker tape? Well, a ticker tape is a long piece of tape, right? And it's a paper tape that goes there, and it goes on a big roll over here. And what happens is we attach it to our trolley with wheels attached to the back, and then we exert a pull on here, which then runs the tape out. Okay, which means we get a long piece of tape. This is attached to the back of a trolley. The trolley's got wheels over here, let's say, like that, right? And we do experiments with this. We put masses on there and things like that. At university, they've got air tracks. Sometimes they've got trolleys as well. But essentially, we are going to exert a force over here. We're going to pull it, and we're going to do experiments. We're going to measure things with it, right? Now, before we do that, we obviously need to make marks on this thing, because we need to measure distances. That is this timer. So the timer, okay, has got a little pin, okay, that's attached to an electromagnet. And what happens is this pen bounces up and down, and it goes like that. You can hear it, right? Now, each time it hits, what does it do? It makes a dot of ink. So I'm going to get a lot of ink dots over there, okay? But the timer, like this, that's, let's say, 1 dot per second, okay? We don't operate at 1 dot per second. We generally operate at things called 50 hertz, or maybe you'll see a 40 hertz question, right? This is the frequency, isn't it? So the frequency is dots per second, okay? Because actually it's a number over. Remember in thingy, it was how many waves pass a given point, stationary point, in a second, right? That measures the frequency, and it's in hertz, correct? Dots per second. We are interested in the time between this dot and that dot there, right? This, let's say, is delta t. Well, remember that frequency was 1 over, what is that? Remember from waves, that's 1 over the period. So therefore, the time between successive dots is 1 over 50, 1 over 40, okay? And if we do the calcs for that, 1 over 50, 1 over 40, let's just have a look. 50 is 0.02. This one is 40, 0.025. What did I work out there? It's 1 over, that's the time. This is the time between successive dots, isn't it? In other words, it's the time between those dots that we're talking about. That is, in essence, our period, right? So what do? We say, okay, now we say, fine. We know we can work out, if they give us the frequency, we can work out the time between successive dots. But look at the time. That's a very short interval of time, right? We don't see it that way. What we see on the piece of paper is a series of dots like that, called A, B, C, and D. Now, yes, if we've got 1 dot to 1 dot, there is delta t, right? The time between dots. But the time is very short. Always look and see if they talk about successive dots or if they talk about a group of dots. They could say, for example, every 10th dot is shown. What does that mean? It means that between A and B over here are actually 10 dots. Okay? There are 10 dots. Now the time between each of those dots is, let's say we're operating at 50 hertz. So we go back up. 50 hertz is a period of 0.02 seconds. So at 50 hertz, it's 0.02 seconds. Right? What does that mean? It means, therefore, the actual delta t, the time interval between A and B, is going to be 10 times 0.02, which is going to be 0.2 seconds. So always look for a group or every so many dots are shown, or if they say successive, then they mean that the time interval is between each one. Okay? It's very important. Okay? Right. Then what do we do now? All right. Well, the next thing, okay, is we let's just do a little recipe for this thing. Okay, let's say step 1, all right, we put in, okay, we are given a schedule that looks like this, A, B, C, and say D, all right? And they give us a distance, usually in millimeters between these, all right? Then what we do, okay, first of all, we've done the calculations above as step 1, where we've got the frequency, then we get the period, we check for how many dots there are, and we multiply it out if necessary. Then we go and we say, right, first over here, convert all to meters, right? Step 1, we make sure we got everything in meters. Why? Because we do kilograms meters per second in physics, okay? Then what we do is we say, right, put in, we've got distance, and call that delta x1, delta x2, delta x3, for example, right? The distances may be the same, they may be different. It doesn't matter. Just put them down in this order. Then put down the time. Okay? Can you see here? Okay? It might help us if we actually, from each point, drew vertical lines down. Good point. Because now we can see what we're doing. So we say, right, this is the distance between you and you, you and you, you and you. Then we put down delta t. But now remember, delta t, delta t. These are all the same. They are the same. Okay, that's the key to this. The time interval between each measured point is the same. All right? Now, okay, so we've now got a distance and a time. Now they're going to ask us questions about this ticker tape timer. They're going to ask, for example, calculate the average velocity, the instantaneous velocity. They're going to ask us about acceleration, accelerations, okay? How do we calculate this? Okay, now the most important part here is just take this down a little bit more. Okay, so I've got the A, B, and the C. Okay, what you do is this. You say, right of all, let's have a look. I don't know the velocity at A. It could have been moving at A. I don't know it. I only know, or we only know what happened from A onwards, don't we? That's it. That's all we know. So what do? Well, we say, here's a trick. First of all, have a look, right? Can you see that this is V, the average velocity is the middle of each point, right? The average velocity is the middle of each point. Now V average is given by distance over time. Which distance? The distance from A to B divided by the time. So it's delta x1 over delta t. This is delta x2 over delta t. This is delta x3 over delta t. Okay? Looks very fancy. What we're saying is these are the average velocities. Okay? They are the velocity between A and B. All right? Therefore, the next question would be, then, what is the actual velocity at B or at C? Those are the instantaneous velocities, right? So they now want V at B, V at C. The simple thing is, basically, it's going to be the average of those. So you would basically take this velocity here plus this velocity here and divide it by 2. It's the average velocity. And ditto, this guy is the V average over there again, isn't it? So all we do is we're just averaging it out. Okay? That's what these are about. We're looking for average. Averages giving us the instantaneous, right? Can I work out what other things are? Yes, we can look at acceleration. How do we look at acceleration? Acceleration, okay, A, whoops, hang on, let me just change that to, let me just change it to blue, okay? Blue, the acceleration is equal to delta V over delta t. Remember, change in velocity over change in time. Change in velocity in physics, V final minus V initial over t. Always the final minus the initial in physics. Remember that? So what do? Vf is equal to V1 minus t, divided by t. So what do? Straightforward. We can calculate. Hello, we know the velocities there and there, don't we? So what can we do? We would just take this as Vf, this as Vi, and divide it by delta t. There we've basically got everything we need to work out the acceleration. We could also have taken the two averages and divided by delta t as well, right? Let's have a look at how that would work. I'll go back to black for that. Let's have a look how that would work, shall we? Well, I've got here V average over here, and we've got, let's say V average over there, okay? This one is going to be Vf, this will be Vi. Remember, I'm now working with the two outer ones, right? So therefore, I've got delta V is Vf minus Vi. What is delta t? Now you have to go back and look. Well, there's one time interval, another. So there's 1, 2, 3, 4 time intervals. So let's look at delta t. 4 time intervals. Of how much? No, not the period. Of the period over 2. Of delta t over 2. The period divided by 2. Let us say, for argument's sake, this was 0.5 seconds. Then this is 0.25. This is 0.25. There's the trick. You have to have a look, and once you've got the averages there, right? When you've got the averages here, remember it's in the middle. This is 0.5. So if I split it into those, I've got each one is 0.25. It's in the middle. So where do we go from here? We count them, and we say the average, therefore, is, or rather the time, is 0.25, 0.5, 0.75, 1 second in that case, okay? We're going to do an example of these, okay? So basically overall, okay, all of these are the same process that we do, okay? It's the same process that we do. Let us have a look at an example, okay? A trolley is attached, and the following are the results at a frequency of 40 Hertz, and every 10th dot is shown. Step 1, read it and look. They say to us, they've given us this, but they say in the blurb, They say a frequency of 40 hertz and every 10th dot. They've given us a frequency, but they've told us a grouping. Okay, so first of all we work out t, which is 1 over 40, correct? 1 over 40, which gives us, let's just check, it gives us 1 divided by 40, and that is 0.025 seconds. Okay, remember what I would do if I were you, I would actually at the appropriate point stop it and write down what I've done. Go through it with me as a process. Right? There we go. But now I've got a grouping, so I must apply this. Because this is time between successive dots. Right? But we've got 10. Therefore, time between A and B on the sheet is going to be 10 times 0.025, which is 0.25 seconds. So the time, and I'm going to draw out on the next page, okay, I'm going to draw out A, B, C, and D, all right? So, well, I can do it here, I suppose. Let's go A, B, C, D, and E, all right? A, B, C, D, and E. And they tell us that this is 150 millimeters, 250 millimeters, 350 millimeters, 450 millimeters, like that, right? Therefore, what did we do now is we've done our step 1. Step 2, convert. Convert there. That is 0.15 meters, 0.25 meters, 0.35 meters, 0.45 meters. Next step is draw down here, let's say workspace, right? This is then delta x1, isn't it? The distance between A and B. This is delta x1. This is delta x2. This is delta x3 and delta x4. That's the distances, okay? Let's rule it off. Now let's put in our time. Time between A and B is 0.25. Delta t is equal to 0.25. Delta t, 0.25. Delta t, 0.25. Each one is the same, isn't it? Because the timing is the same. All right, let's rule that off. Now they say, calculate the average velocity between B and C. Okay, they want average velocity between B and C. So let's go to red, for example, shall we? Average velocity between B and C, so we put in what we are looking for. Average velocity there, right? Average velocity is equal to delta x over delta t, which is going to be, this is question 1, the average velocity there is 0.25 meters divided by 0.25 seconds is equal to 1 meter per second, or ms minus 1. Do you see that? The distance that we travel, 0.25 divided by the time. The average velocity is given by the distance over the time, and that puts us in the middle. So we've worked out the average velocity in B and C. The next, the instantaneous velocity at B. Okay, now they want VB. Right, let me change that to green, just so that I've got just a slightly different thingy. Let's change this to, they now want V at B, right? Well, now it's at that point there. Now we have to use the total distance that it traveled here over the total time there. So the velocity at B is total distance it traveled was 0.15 plus 0.25, this one plus this one, divided by the total time is that one plus that one, isn't it? It's 0.25 plus 0.25. Okay, so we get 0.25 plus 0.15, 0.25 plus, okay, 0.25 plus 0.15 equals that, divide 0.25 equals, divide 0.25 equals, okay. Kevin made an error there. Sorry, my apologies. It's 0.25 plus 0.15. I think I times that equals that, divided by, which is going to be 0.5 is equal to 0.8 meters per second. Right? That's 0.8 meters per second. So when we've got that, can you see? All we've done, let's look at the pattern of doing these if you like. Okay, let's look at the pattern of doing these things. Here, the first one, I took this piece. There I was. The next one, I've moved to there, so I've got to take all the piece above me. So they say calculate the instantaneous velocity at D. All right, let's go to the instantaneous velocity at D. They want over here. V at D. So what do we take? Well, we need all of this, don't we, to get that. So what's our distance is going to be? The distance is 0.35 plus 0.45 divided by, it's still 0.5 seconds, right? Therefore, the answer comes out there to be 1.6 meters per second, okay? Now then they say, calculates the average velocity between D and E. Right. The average velocity, I'm going to go back to red. Red is the average over here. The average velocity here is what? Is that distance over the time. Is 0.45 divided by 0.25. Okay? So V average over there is 0.45 divide 0.25 is going to be equal to 1.8 meters per second. Okay. Now, the last thing is they want to know the acceleration of the trolley. Right? Acceleration of the trolley. What do I do? Well, the acceleration of the trolley, quite straightforward. I now go and look, where have I got any two known velocities? Let me link these two first, shall we? 0.8 meters per second and 1.6 meters per second. So therefore the acceleration is delta V, delta T. What is delta V? V final minus V initial. V final is the one further out in time, is going to be 1.6 minus 0.8, right? Over, what is time? Well, let's look. It's there and there. It's 0.25 plus 0.25, correct? So 1.6 minus 0.8, 1.6 minus 0.8 is equal to 4 over 5, divide 0.5 is equal to 1.6 meters per second squared. Okay, or S minus 2, same thing, isn't it? Right? Do you see what I did? I said, I know this velocity and I know that. So I find a VF and a VI and I count the number of time intervals in between. Let's have a look at it another way. Let's say, all right, let's use the two V averages that we've got, right? The V average, I have got a V average over here of 1 meter per second and a V average over here of 1.8 meters per second. This is the final one, is the further out in time, 1.8 minus, okay, 1.8 minus 1 is that. And what is my time? Now you've got to be careful, right? Let's count. I'm just going to go back up here and let's count these, shall we? I've got from there to there. That is, okay, there we go, and there we go. We've got to get to there, okay? So, right, where are we? We've got 1.8 minus 1. Now we've got to add into it what? Well, this time over here is 0.25. This is 0.125. This over here is 0.125, isn't it? All right? So what do we end up with? Okay. We end up with this 0.25, middle one, plus 0.125 plus 0.125, which is equal to 0.8 divided by 0.25 plus 0.25, which is going to be 1.6 meters per second squared, right? That is how the ticker tape works, right? The next one, all right, we're going to start looking at energy, all right? I know this one has gone on fairly long, but the next one we're going to look at energy, and I'll do probably another ticker tape timer that I've got over here as well, all right, where we've got some other things in it. Thanks for watching. We're almost at the end of the things apart from exam and test preparations. Thanks for watching, and hope we'll see you in the last one.